Hi everyone, I hope you're okay. This is the ninth video, guys, which simply means I'm doing question number 9 from the past exam question papers, but I'm only tackling work energy and power questions. Please note that, guys, in total there will be 11 questions, and all of those questions are uploaded on the link on the link below. If you just click the link below, it will direct you to the playlist with all 11 questions rather. And all of those questions, guys, they are extracted from past exam question papers. Just stay tuned, guys, and wait for more videos. Let's start. A demolition ball is used by a crane to break the wall of a building. The demolition ball of mass 1,250 kilograms is lifted by the crane to a point R at a height of 5.8 meters above its lowest point in 60 seconds. Okay, we must ignore the effects of air friction. First thing they want us to do is to define the term power. Okay, power is the rate at which energy is dissipated, or you can say is the rate at which work is done. Okay, and then 5.2, they want us to calculate the average power dissipated by the crane in lifting the demolition ball to point R. Okay, the first thing we need to do, we need to find that because there is a change in potential energy there, we need to find the for us to find the power. Power is the rate at which energy is transferred, right? So we can simply say, we can see there's change in potential energy, that's energy, and then over change in time. Are you together? So in this case, change in potential energy is just mg final height minus the initial height all over the change in time. The mass of the crane is 1,250. Final height, that's 5.8 meters. That's initial height is 0. This happened in 60 seconds. So I simply have 1250 multiplied by 5.8 minus 0 all over 60. This will give me 120.83 watts. Okay, so that's my average power. That's my average power. Then I'm told that the demolition ball is released from point R and strikes the wall at the lowest point of its swing. Okay. The ball then moves 0.5 meters horizontally into the wall before coming to rest. Oh, okay. The first thing they want us to do is to define the term conservative force. Conservative forces are forces whose work done is not path dependent. Are you together? Are forces whose work done is not path dependent. Okay. The force of the wall, the force which the wall exerts on the ball, is the force which the ball exerts on the ball a conservative or a non-conservative force? It's a non-conservative force. Are you together? Action-reaction force, guys, is always a non-conservative force. It depends on the path taken. Then I must state the energy conversion that takes place during the downward swing of the demolition ball. In here at point R, guys, we only had potential energy. This crane was held at rest. But when it gets released, this potential energy will be converted to kinetic energy. That's why there is movement. Are you together? So energy conversion, it happens from potential energy to kinetic energy. Are you together? Okay, so now I'm supposed to use energy principles to calculate the magnitude of the average force exerted on the ball while it moves into the wall. Remember that, guys, I just said the energy conversion that takes place is kinetic energy to potential energy, né? No, like vice versa. Are we together? If we're going to call this position W, we can simply say that mechanical energy at R is equals to the mechanical energy at W. There are no non-conservative forces whenever the crane is released. They said we must ignore the effects of air friction, and there's no applied force. So it's like a pendulum. Are we together? So mechanical energy has to be conserved because we have an isolated system. So mechanical energy at R is equal to mechanical energy at the wall, or W. Okay, and then I know that this is mgh at R plus kinetic energy at R. It has to be equal to the mgh at the wall plus the kinetic energy at the wall. I'm doing this, guys, because I want to find the final velocity when the crane just before the crane hits the wall. All together. So but there are things that I do know. I do know that initially at position R the crane was held at rest, so the velocity was 0 meters per second, and hence the kinetic energy will be 0 joules. Are we together? And then at point W, there at the wall, the height above the height of the crane above point W is just 0 meters high, and hence its potential energy will also be 0 joules. So I'll simply have a 0 over there. All I have to do is to just substitute the potential energy. That's 1250 multiplied by 9.8 multiplied by 5.8 plus 0. And then on the other side, I'm looking for the velocity just before it touches the wall. Okay, on the right hand side I have 120 oh no, it's 1250 multiplied by 9.8 multiplied by 5.8. That's 71050 being equals to 600 velocity squared. If I divide both sides by 600, what do I get? I simply get the velocity to be equals to 118.41666667. Then put the square root on both sides, and then the velocity at position W is just 10.88 meters per second. Did I answer the question? No. After the crane, guys, hits the wall, this is the wall, and that's the crane hitting the wall. The crane will travel a distance of 0.25 meters as it was indicated horizontally. Are we together? It will travel a distance of 0.25 meters horizontally, and then it will come to a stop. Are we together? So now they want us to find the force. Calculate the magnitude of the average force exerted on the ball while it moves into the wall. I simply know that work net is equals to the object's change in kinetic energy. There's only one force here, guys. It's the action reaction force. It's the force of the wall on the ball multiplied by delta x cos of theta. This is equal to the change in kinetic energy, right? Half mv squared minus half mv squared. That's initial and final. Okay, I don't know the force, but I do know that my object will travel a distance of 0.25. Are you together? Cos of 180 degrees. Why? The ball is trying to push the wall towards the right, and same thing applies. The wall will try to push the ball towards the left. If body A exerts a force on body B will exert an equal but opposite force on body A. All right, together. Okay. After the crane ball has just traveled for 0.25 meters horizontal, it will come to a stop. And whenever it comes to a stop, its velocity will be 0. When the velocity is 0, the kinetic energy will also be 0. All right, together. And then now I do know that I have negative 1 over 2 multiplied by 1200 and then 10.88 all squared. I will simply have negative 0.25 multiplied by F wall being equals to half multiplied by 1200 multiplied by 10.88 all squared. That's negative 71,024.64. Ne? Then I'll obviously divide both sides by, let me check. I'll obviously divide both sides by the negative 0.25. The force will be 284,098.56 newtons. This is how, guys, we're supposed to tackle this question. I really hope that the video helped you out. Thank you very much.